Hey guys, it's Miss Manili, and this is part 2 of your midterm review packet. I'm going to go ahead through the probability unit now. Originally I thought I would just do 20 to 23 and 25, but I'll go ahead and do 24 as well. So I'm going to go ahead and begin at problem number 20. You're given a two-way table. The checking accounts of Save More Bank are categorized by age of the account and the balance in the account. And we're going to select an account at random from this group of 2,000 accounts. So we already know the total, which is nice. And if it helps, you can go ahead and add the totals. These are the marginal distributions that we would be finding here. So if I add up each of the rows, I could find out. I know that there are going to be 1,200 accounts that are less than 3 years old and 800 accounts that are more than 3 years old. I'm also going to go ahead and define how I'm going to be referring to these events. So if this is a free response question, you'd want to make sure that you label. If you're going to be using abbreviations or initials, you want to make sure you label everything. And then I've got my accounts that have different value amounts. So I have my first set that have $0 to $99. I'm going to call this A, and there are 900 of those types of accounts. The 100 to 499, I have 500 of those. I'm going to call that event B. And the 500 or more, I'm going to call that event C, and there are 600 of those. All right, so in letter A, it says to determine the probability that an account is less than 3 years old and has a balance of 500 or more. So I'm looking for the probability that it's less than 3 years old, so I'm calling that 3 minus, and that it has a balance of $500 or more. So that's my event C. Now, you don't have to use your probability rules here because of the way the table is set up. I'm essentially looking for the number of accounts that are both less than 3 years old and have more than $500. So I'm talking about this number here. I'm talking about 400 of these accounts. There's no condition that's been placed, so I'm talking about the 400 out of 2,000. In the next one, it says determine the probability that an account is at least 3 years old or has a balance between 0 and 99. So this is an or statement. So I'm looking for the probability at least 3 years old. I define that with a 3 plus. I'm going to use the word or because that's what it tells me to do. And I'm looking for between 0 and $99, which is letter A. Now, in this case, there's several ways you can do it. You could use your probability rule here, which would be the probability of 3 or more years old plus the probability of A minus the probability of both. You could certainly do it that way. Or you could sort of just check off which accounts fall into these categories. So it's got to be at least 3 years old and have less than $100. So if I look at, if I just kind of go down each column, that would include this 700 because there's less than $100 there. It's got between 0 and 99. This is going to be included also because it's less than $100. If I look at my next column, if I've got accounts that are less than 3 years old but over $100, it's okay because oh, no, it's not. I'm sorry. Since they're not less than 3 years old and they're more than $99, that's not going to be included. But basically, any account that is 3 or more years old is going to be included. And anything that, as well as any of the accounts that have between 0 and $99. So there's 4 different possibilities here. So if I added all those values together, we've got 700, 200, that's 9. That's going to give us 13, 14, 1,500. Out of 2,000, and that would be the probability. If you wanted to use the rule, I can do that as well. So I'd be looking at the probability that it's at least 3 plus the probability of being between 0 and 99 minus the probability of both. And so the probability of being at least 3 years old, I'd want to make sure that I add the whole row. So that's going to be 800 out of 2,000. And then I'd add that to the probability of having a balance between 0 and $99. That's 900 out of 2,000. And then I'd subtract the probability of both, and that would be the 200 out of 2,000. And since we have the same denominator, basically I have 800 plus 900, that's going to be 17 minus 2 is also going to give me 1,500 over 2,000. So notice that either way you do it, you get the same answer. In letter C, it says determine the probability that an account has at least $100. So that's going to include all of the accounts that are in B and C, or C. So we're looking at the probability of B or C, which would basically be 500 over 2,000 plus 600 over 2,000, which would be 1,100 over 2,000. And those events are disjoint. Letter D says, what is the probability that an account has a balance under $100 given that it is less than 3 years old? So now we've got a given here. We're trying to find the probability of under 100. So that's going to be our event A, given that it's less than 3. Oops. All right, so whenever you have a given, that means you're restricting the outcome, the denominator. Okay, so if I'm going to be looking at just the accounts that are less than 3 years old, it's just this 1,200 accounts that I'm looking at. If they also have to be less than $100, then there are 700 of those out of 1,200. And obviously, in all of these, you should be simplifying the fractions. In letter E, it says, are less than 3 years old and balance under 100 independent? Why or why not? Well, if they're going to be independent, then I know that the probability of less than 3 and under $100 would be event A, would have to equal the probability of less than 3 times the probability of A. And I'm wondering, is that true? Well, the probability of being less than 3 and having less than $100 is going to be 700 out of 2,000. And I'm trying to figure out if that is equal to the probability of being less than 3 years old would be 1,200 out of 2,000 times the probability of A, which is 900 out of 2,000. And so when you simplify, I think you end up with 0.35 here. I'm just going to do this up here. And then when you multiply those two fractions, you end up with 0.27. And since those values are not the same, the events are not independent. Letter F says, suppose 5 accounts are drawn at random from this bank. We're going to let the event G represent at least one of the accounts is less than 3 years old. If we assume the accounts are independent, then what is the probability of G? So we're trying to find the probability that at least 1 in 5, and we're saying are less than 3 years old. Okay, and remember, anytime you're dealing with the at least one, that's going to be an or, so it means that it could be 1, or it could be 2, or it could be 3, it could be 4, or it could be 5. And when you have so many different options, then it's easier to just look at this in terms of its complement. And it would be 1 minus the probability that none in 5 is less than 3 years old. So if I know that the probability of being less than 3 years old is 1,200 out of 2,000, then the probability of being over 3 years old, or not less than 3, is going to be 800 out of 2,000, which I believe is 0.4. And so I'm looking at 1 minus, if I'm looking at none of the 5 accounts are less than 3 years old, that means they're all over 3. And since there's 5 of them and they're independent, I'm looking at the first one is over 3, and the second one is over 3, and the third one, and the fourth one, and the fifth one. With and, I multiply. Since I have independence, I can just multiply 0.4 times itself 5 times, or simply 1 minus 0.4 to the fifth, and we get 0.9898. Okay. Number 21 helps to draw a Venn diagram. It says insurance company records indicate that 12% of all teenage drivers have been ticketed for speeding and 9% for going through a red light. 4% have been ticketed for both. So I'm going to go ahead and draw a Venn diagram here. I'm going to use T for ticket, R for red. Okay. And I know with a Venn diagram, we always want to start with the overlap if possible. And so in this case, we know that 4% have received tickets for both. I know that 12% have been ticketed for speeding. Oh, I guess I want to call this S for speeding and not T for ticket. Let me clarify that. All right, so we said 0.04 in the middle. If I've got 12% that have been ticketed for speeding, Remember, that includes this whole circle, which has the 4% already in it. So I've got to deduct the 4%, leaving me with 8% getting a ticket for speeding alone. And then with the red light, I got to subtract the 4% from the 9%, and that leaves me with 5% getting a ticket for just a red light and not speeding. If I add those values up and subtract them from 1, that means that 83% did not get a ticket for either of these reasons. So in question A, it says, what is the probability that a teenage driver has been issued a ticket for speeding, but not for running a red light? But is just another way to say and. So we're looking for the probability of speeding and not red. I think it helps in this case to actually think about what it means to be an intersection. So I'm actually going to look at this. Let's see. I'm going to do a highlighter here. And I'm going to use, let's start with yellow. So if I'm looking at the probability that it is, that the teenager is speeding, then I'm going to go ahead and color in this area here. And if I'm also looking at them not getting a ticket for running a red light, I want to make sure that I color in everything outside of my R circle. Okay. And so if I look for the overlap, if you think about it, blue and yellow make green, so that's going to be where they overlap, and that's what and stands for. It's the overlap, it's the intersection. And so I can tell when I look at my Venn diagram that I'm just looking at that 8%. In letter B, we're asked what is the probability that a teenage driver gets ticketed for at least one. That means they got ticketed for speeding or running a red light. And if you remember with the or, it's a union, and the union is going to include everything inside both circles. Okay, you just want to be careful that you don't count the overlap twice. So if I add up all those values, I've got 8%, 4%, and 5%. That's going to be 17%. And then in letter C, what's the probability that a teenager has not received a ticket for either offense? That would be the probability of not S and not R. You could also look at it as not S or R. In either case, that's going to be your 83% on the outside. Number 22 says 6 Republicans and 4 Democrats have applied for 2 open positions on a planning committee. Since all applicants are qualified to serve, the City Council decides to pick the 2 new members randomly. What's the probability that both come from the same party? Well, that means that they could either both be Republican or both be Democrats. So let's write that down. The probability of both being Republicans means R and R, or both Democrats. That would be Democrat and Democrat. So if I think about this situation, I know those are disjoint. I can't pick 2 people that are both Democrats and Republicans, so this is the same thing as the probability of R and R plus the probability of D and D. Okay. Now in this case, this is similar to like drawing cards out of a deck. Once I pick somebody for the City Council, I'm not going to put him back in the pool and risk the chance of picking him again. So in this case, we do not have independence because the probability of selecting the second person is going to change depending on who you selected the first time. So I've got to think about this. The first Republican, or the first person I pick, the probability that that person is a Republican, well, I know there are 6 Republicans and 10 people total. So the probability of that first person being a Republican is 6/10. But he doesn't go back into the pool. Now there's only 9 people left. And if I'm looking for the probability of picking another Republican, there's only 5 left in the pool. I also want to consider the possibility of drawing 2 Democrats, so I'm starting over again. The probability that the first person I pick is a Democrat, well, I know that there are 4 Democrats and 10 people altogether, but if I don't put him back in the pool, I know that there are going to be 9 people left and only 3 of them will be Democrats. So when you simplify that expression, you end up with 0.467. And number 23, it says according to the National Telecommunication and Information Administration, Let's see. 56.5% of U.S. households owned a computer in 2001. What's the probability that of 3 randomly selected U.S. households, at least 1 owned a computer in 2001? All right, so again, we're looking at the probability of at least 1 in 3 owned. And you could find the probability of 1, the probability of 2, and the probability of 3. Or you can do 1 minus the probability that none in 3 own, which is going to be easier. We're told that the probability of owning is 0.565. That means the probability of not owning is 0.435. Okay, so I'm looking now at 1 minus the probability that none in a group of 3 own a computer. That means the first person does not own, and the second person does not own, and the third person doesn't own. I can assume independence here, and so that would basically be 0.435 times 0.435 times 0.345, or 435, and so that's the same thing as 1 minus 0.435 to the third, and that's going to be 91.77%. Okay, number 24, it says a manufacturing firm orders computer chips from 3 different companies. 10% come from company A, 20% from company B, and 70% from company C. Some of the computer chips that are ordered are defective. 4% of the chips from company A are defective, 2% from company B, and 0.5% of chips from company C are defective. You're asked to draw a tree diagram. Well, the first thing is going to be where the computer chips came from. We've got company A, B, and C. We're told that 10% come from company A, 20% from company B, and 70% from company C. You do want to just double check to make sure that that adds up to 1. Then our second stage is going to be whether or not they're defective. So I'm just going to use D or not D for defective. D, not D. D, not D. All right, so I know if I'm dealing with company A, 20%, I'm sorry, let's see. I know that 4% of company A's chips are defective, so I'm going to do 0.04 here, 0.96 are okay. And then from company C, we know that 2% are defective. That means 98 are fine. And lastly, from company C, we know 0.5% of the chips. Be careful with the 0.5 because we need to move the decimal place 2 units. So that's going to be 0.005, which gives us a 0.995 chance that they work. Letter B, it says a worker at the manufacturing firm discovers that a randomly selected chip is defective. What's the probability that the computer chip came from company B? So if we know that it's defective, that's given. So this is a conditional probability. And so I know it's defective. I'm trying to find the probability that it comes from company B. So I'm going to have to use my rules here because of the way my Venn diagram is, or I'm sorry, the way my tree diagram is set up. The given isn't the defective information. The given depends on the company. So I have to rely on my probability rule, which tells me that it's the probability of both B and D over the probability of the given, which in this case is D. All right, so the probability of B and D is basically this path right here. And so remember, we multiply along the branches. 0.2 times 0.02. The probability that it's defective, though, there's several different ways that can happen. It can happen here, it can happen here, it can happen here. So I've got to consider all those paths. So if I take the first path, that's going to be 0.1 times 0.04. Or it can be the second path, which means I need to add it to 0.2 times 0.02. Or it could take the third path, so I need to add that to the 0.7 times 0.005. And that should give you 0.6222. All right. The last problem deals with random variables. And I'm actually going to create a little table at the bottom of the screen just to kind of help organize everything. It says for test 1, I'm going to call that T sub 1, the class mean was 80. So let me do this. Mean. I'm going to go ahead and do the variance next, and then the standard deviation down here. All right, so the mean for test 1 was 80, it had a standard deviation of 10, which means that it had a variance of 100. And then we have for test 2, we have a mean of 70 with a standard deviation of 12, which means we have a variance of 144 if we square it. And then in letter A, it says, what is the mean for the two tests added together? So I'm looking for T1 plus T2. And remember, whatever we do to the random variables, we can do to the mean. So I'm just going to add 80 plus 70, and that gives me 150. I guess this is points. In letter B, it says, what's the standard deviation for the two tests added together? Well, remember, we can't add the standard deviations. We have to work with the variances. So if I add my variances, I get 244. To get the standard deviation, I take the square root of that. And let's see, you should get 15.62. Okay, the next to deal with the difference. So if I'm looking at T1 minus T2, actually let me do this in a different color. All right, so if I'm subtracting, I'm doing 80 minus 70, which gives me a difference of 10 points. The standard deviation of the difference, though, remember, I never subtract my variances. I always add them. So I'm actually going to have the same variance that I had before, because when I add I'm going to have the same variance and standard deviation as before because I'm adding them together. So this is still going to be 15.62. Okay. In letter E, it says, if I cut the test scores on test 2 in half and add 50, what's the new average? So we're looking for half of test 2 plus 50. All right, so the mean, again, this is just going to be straight up 1/2 times the mean of test 2, which was 70, plus 50. That's going to be 35 plus 50, which is 85. The standard deviation, though, remember, I have to work with the variance. So when I'm multiplying by a coefficient, I'm going to square that 1/2. And so I'm going to do 1/2 times the variance of test 2, which was 144. And then I'm going to take the square root of that. So let's do that up here. So if I take the square root, where's my square root? There's my square root. I'm going to do 1/2 squared. I'm just going to write that as 0.5 squared times 144. And that gives me a standard deviation of 6. Okay, let me actually just make one other additional comment about the standard deviation, the variance in letter F. Notice that I did 1/2 squared times the variance, but I didn't add the 50. And that's because, remember, with your spread, adding and subtracting a number isn't going to change the distance between your values. So the spread doesn't change when all of your values increase by 50. So that's why we don't worry about adding that to the variance. All right, in letter G, it says if I add 7 points to every test 1, what's the new standard deviation? Well, again, it's not going to change because adding points to every value in your distribution doesn't change how spread apart they are. So the standard deviation for test 1 is going to remain 10. And then in letter H, it says if we multiply every test 1 by 2 and subtract 80, what's the new mean? Sort of running out of space here, so let me just erase this. All right, so if I have multiplying test 1 by 2 and subtracting 80, so I can do that to the mean, so it would be 2 times 80 minus 80 is just going to leave us with 80. And same thing, if I wanted to find the standard deviation, again, I still have to work with a variance. But remember, if I'm multiplying by 2, I've got to square it, then multiply it by the variance of the test. But I'm not going to subtract the 80 because it's not going to change the spread. So basically, I'm going to have 400, and the square root of 400 is 20. All right, so I hope that clarifies everything. Remember, the Quizlet is available to help review all the terms that are in the second unit, which is the the studies, doing the experiments and the observational studies. So if you have any questions, obviously come in during Bulldog Block on Friday. You can stop by to see me during the break anytime next week if you have any other questions. So good luck.